Okay, so welcome to this webinar from Netskope regarding ZTNA, Zero Trust Network Access. We do take questions on the chat, so if any questions pop into mind, just let us know. I think that we have a little hour ahead of us, and we're gonna take you through some exciting news, which is that we want to retire VPN solutions. Maybe that's not too new, but we have come up with a product called ZTNA Next, and that kind of eliminates the last reasons for keeping a legacy VPN. So we are thrilled to talk about that today. And with that, I will introduce my colleague Paul, who is a subject matter expert on this field, Paul Beleveld. Can you maybe switch slides to the one with a little bit about yourself? There we go. So Paul has 20 years of experience in the cybersecurity field, and he's going to take you through ZTNA as in general, and VPN retirement as in general, and then also, of course, ZTNA Next. So with that, Paul, I leave it up to you.
Thank you for the introduction, Daniel. It's a real pleasure to spend some time this morning with everybody on the call. I guess, there's a lot of confusion at the moment in the market around zero trust network access. And in reality, the concept has actually been around for a very long time, but it's only been recently been made more popularized by some of the analyst houses and the papers that were delivered. So we're going to try and cover a number of different topics, but we also want to make this interactive and interesting. So let's start off with a poll, and we're going to discuss, and I want to elicit some feedback from everybody on the call this morning to give us your input. I guess let's run the poll, the first poll. So right now you should be able to see a poll that says, which of the following defines zero trust? And I guess there's no right or wrong answer here, but it's really about how do you see zero trust, or what do you believe zero trust is? Right, and we'll give a few moments just to complete that poll before we'll review the feedback.
Let's see if that came in. There we go.
Right, so so we have some poll results. There's effectively two opinions, right? It's the same thing as zero trust network access, as well as it represents a set of principles that guide an improved way. So, I mean, zero trust network access is one implementation of zero trust, but I guess the fundamental premise of zero trust is the fact that what you're trying to achieve is avoiding all possible situations of implicit trust, right? That's really the purpose of zero trust, is we want to ensure that we do not have any form of implicit trust. And that might mean that we have multiple different signals that we need to accommodate when we build policy. Right, so that's great. So that's the first poll. Let's get back to the some of the content. Thanks for those responses. I think it's always insightful to get feedback. Now, some of you might be in IT for some time already, and this will look very familiar, right? There's this concept of security or IT security that was always defined by network location. It was essentially a firewall that governed an untrusted zone, the public internet. All the bad guys were out there, right? We had a demilitarized zone where we had our firewall create a place for our service that was exposed to the public internet. And then we had a trusted zone, the inside of our network, which is, this was the highest level of trust and where everything was perfectly fine, right? And that's the view. That was the traditional view of cybersecurity, and in many cases might still be the view. Now, if we look at then how did this trust move to remote users or users working from home or remotely, the idea was to take that trust of a user sitting on premises and make that remote user part of that on-premises network while they are remote, essentially extending the trust from the on-premises network to the remote user working from home or from Wi-Fi or through VPN as a technology, remote access VPN as a technology. But what we need to point out with this architecture is there's a lot of implicit trust here. The trust that is granted is based on the fact that the device or the user is on the network and it's trusted implicitly. And that is really the type of thing that we want to avoid when we talk about zero trust. Right? Zero trust could take into account network location as a signal to the policy, but it should not be the only premise of which trust is granted on. Right. Now, if we fast forward and we think about what the challenges of today is, we realize that things have changed. We no longer just have simple one network locations with a firewall that can govern trusted, untrusted, demilitarized zones. We now have software as a service applications living on the public cloud. We have both managed as well as unmanaged software as a service applications. We also have data centers in many different locations, private data centers in my own network, or private cloud data centers, which relies on virtualization technology, but also public cloud data centers. Our applications hosted in AWS or Azure, and multiples of these applications in different locations, different regions, which means that our data is lots of different places. And at the same time, our users have been spread across different locations, right? Now, if we think about the controls that we traditionally had to protect our data, it becomes challenging, right? Because we have all of these different controls. The networks are no longer at a specific place. So it becomes really hard to scale controls to protect data everywhere. And if we start saying that, more than 50% of threats are cloud enabled, they leverage software as a services apps. 60% of traffic on our corporate networks today is actually software as a service or cloud traffic. So a significant amount of our day-to-day activity relies on applications that is not even hosted in our own data center, and it's not under our control, but our data is still something that we need to protect. Right. The other big thing is encryption of data, right? Encryption is a really good thing because it provides us confidentiality and integrity of our information, but at the same time, it also makes it difficult for us from a cybersecurity perspective to protect that data, because it's the traditional network edge defenses is not able to look inside that encrypted data and see the malware or the data inside. Now, if we bring this discussion back to a VPN discussion, right? So, and we think about what is actually wrong with legacy VPN. Well, there's a number of different things that fail today. One of the biggest problems we face is performance. If we have a lot of users working remote, which we've seen that happening during COVID, and it's carrying on still after COVID. All of those users' traffic needs to be tunneled back to the VPN concentrator in order to access private applications. But those private applications are not always just on premises where that VPN concentrator exists, but potentially it's connected over a WAN to different types of, different locations, also cloud or other data centers. And that means the data traverses networks potentially multiple different times, and it routes between data centers, which adds latency and potentially performance challenges. Additionally, it's complex from an architecture perspective because you have to build WANs, you have to do data center interconnects, you have to create routing, so there's traffic routes, you have to create your access control lists to allow these users to access only the applications that they need to access. It's hard to scale. These things are scaled by adding additional hardware appliances, so it's not very elastic. And then the digital attack surface is still significant, right? Brute force attacks on public-facing VPN concentrators is one of the most popular ways that attackers gain access into corporate environments. And we're seeing that those attacks have really increased since the last few years. So there was a Gartner study conducted asking, what are the top challenges in supporting the remote workforce? And some of those challenges highlighted, or the challenge highlighted the most often was home networks and personal internet connections, which is, challenge. Connectivity is a problem. And why is that a problem? It's a problem because potentially meetings like these, could be choppy. It might be latent and not give a good user experience. So quality of experience really matters for remote workers. Patching and corporate managed endpoints is a challenge. Supporting those remote users when there's a problem on their machines is a challenge. How do you actually solve problems like patching machines, supporting them, the device lifecycle, and so on and so forth. And this is going to lead us into our next poll. So let's run that poll quick. And the question we're asking is, how are you currently achieving adaptive or unified adaptive zero trust for users on and off the network? And there's 4 options: always on full tunnel VPN, cloud security services edge, client software. I do not have a unified approach for on and off network user. Okay, so the poll results are in, and this is really a mix of a number of different things. 43% of respondents points out that they have an always-on full tunnel VPN, right? So that's the very traditional approach of, I have invested in security hardware at my network edge, and I want to leverage that investment. And it's pretty much what I have, and I have to work with it. So there's still a large contingent of people using that approach. Cloud security services edge adoption seems still pretty low. And then there's also I do not have a unified approach for on and off network users. And I guess that's why you are here, right? So we can offer some insight and what we are doing and how we are helping customers, build that or deliver on that. Right. So I'm gonna switch to the next slide, but I would want to encourage you, if there are any questions as we carry on through this talk, to please post those questions in the chat. Daniel is monitoring those questions and he'll raise them up so we can have them answered as they come up. Right, so what is Netskope pioneering, right? So Netskope is essentially a cloud-delivered security as a service platform. And in this platform, we are delivering a number of different controls that is looking to ensure that we deliver security first and foremost, and secondly, quality of experience for our users. Now, if you think about the controls that generally would deliver these different capabilities from a security perspective, we're talking about your traditional edge controls, things like cloud firewalling or secure web gateway, remote browser isolation. Those types of controls that allows us to do control of cloud applications, protection of data in motion, threat protection, that would be similar or traditionally delivered from a network edge perimeter. but leveraging the power of the cloud to do it in an elastically scalable way. On the other side, WAN edge services is the concept of connecting users to applications and doing that in an intelligent way. So that's the other component of what Netskope is delivering inside the SASE vision, if you like. So regardless of where my users are, and regardless of where my applications are, either external or private, ensure that we have security as well as quality of experience for our users accessing those applications. And essentially, the way that we are doing this through this secure access to web and software as a service is we do things like allow users to access applications directly, right? So we shorten the path. We ensure that users can access those cloud applications in the shortest possible path to reduce our latency. We then give visibility into what users are doing so we can govern, IT and ensure that we don't have any non-sanctioned applications in use, which creates risk. We coach users in real time. So we don't just allow or block, we also offer users, the data custodians that might by accident expose data through an application that's not sanctioned for corporate use. We can coach those users and warn them and tell them, don't do that, rather use the corporate sanctioned instance or corporate sanctioned application. Right? And then we also reduce things like risk through threat protection, isolating certain applications if we need to, all the other controls that's around protecting that data and the user experience. And from a second perspective, we also secure access to private applications. This is very often where zero trust network access comes in. We use a ZTNA policy and an engine to ensure that we look at lots of different things. We call them signals, if you like. Understand what the context is of the application, understand what the context is of the connecting user, device, and the data associated to that connection, and then deliver on, again, a more seamless direct path, a solution that is elastically scalable. That means we're not tied into hardware on a specific location, but it scales out across many different locations in a cost-effective way, really giving us that agility that we need in this cloud-first world. Right, so the goal is to move from this traditional approach of having the static network location security controls. It's like I've got a trusted, demilitarized, and trusted zone, and all of my policies are based on IP addresses, where the user's coming from, and where the user's going to a more modern approach, which is a contextual risk-aware approach, right? It's like I understand what the application is, I understand what the activities the user's performing, and I continuously look at, has this machine potentially been infected with malware, and now there's suddenly risky user behavior. So there's a user risk associated to this device, and therefore adapt the control and the level of access and permission in real time, so that we can maybe perform a step-up authentication, require the user to do a second factor auth before they are able to continue accessing the application going forward. Right? And that is really one of the big things around delivering zero trust. It's granularity of visibility. And it encompasses things like device trust, location trust, app trust, instance of the actual application, the activity that the user's performing. Obviously, if you think about it, download activity might pose a lower risk or a different type of risk to an upload activity. Obviously, downloads might contain malware, but uploads might contain sensitive data, and that context matters, right? And what Netskope does in order to address that, obviously, we have to decrypt inside that engine, again, leveraging the power of the cloud to do real-time inline decryption, so we can see what users are performing, and then we can use these different signals as input to our zero trust engine. So I guess I'm gonna just pause for a moment and just ask Daniel, is there any questions that we need to answer at this point?
We don't have any at this moment, but it might pop up. So you can just go on.
Great. So what we'll do is we'll ask another poll. I think that makes sense. Let's bring up the next poll. Right, so this poll is, do you have any method for using user behavior risk to enforce adaptive zero trust access to apps? I guess it's always nicer to be in person, you know, and ask these questions face to face. But the nature of a virtual event means we have to use tools like this. So the vast majority on this poll essentially said no to having a adaptive zero trust access to apps. And I guess this is something that Netskope can really help with in a number of different ways. But to briefly give you an explanation of the kind of thing that Netskope does here is because we are monitoring users' behavior in the cloud, you know, decrypting cloud apps and understanding what data is moving where, we can use user behavioral analytics to detect potentially bad behavior. And we leverage technologies like machine learning to understand or model that behavior against bad things. So for instance, one very simple rule that can trigger is a user copies data from their corporate OneDrive for Business cloud storage solution to their personal Dropbox environment. And maybe that user just did it because they want to find an easier way of sharing data. But that action could result in a bad behavior, right? It's a way of potentially exposing data through a tool that is not managed by corporate networks, and that would be an input for user risk, and that user risk score can then be used in our adaptive zero trust access control to then perform a certain action. It could be a coach, it could be a allow a block, it could also be a step-up authentication to require multi-factor auth the next time that user tries to log into a corporate instance. And there's many of these types of engines. There's other ones that deal with ransomware activity, suspected data loss in different ways. Very powerful, and it does allow us to implement that adaptive zero trust access to applications. Right. So let's change a little bit to the topic or the theme of Netskope Private Access, which is the product name of the Netskope Zero Trust Network Access Solution. So ZTNA, and that's the acronym. And if we think about why we would want to look at adopting a zero trust network access approach to allowing remote users access to private applications, and that's simply because of the precision that it provides us, right? So Gartner says ZTNA provides adaptive, identity-aware, precision access, and it removes that implicit trust which is gained through the network location, right? And which is really an advantage which eliminates excessive implicit trust, right? That's the key to why you would want to deploy zero trust network access. But there's a lot of other benefits. Adaptive means we can react. We can change the level of access depending on the signals that we get from the input of the engine. It is not just IP addressing; it's also identity aware. And it's application access, right? We're talking about a policy that grants access one-to-one. This user potentially is accessing this application on this port. It's not this user is accessing the network and therefore they have access to the application. So it's one-to-one access. It's policy driven. Really, precise, right? So what Gartner also says is by 2026, 75% of workers will continue to split time between home and traditional office locations. And I guess what's important to realize here is that even though you might have people returning to the office full time, they will most likely still have a mobile device, which they will use in the evenings to connect into the office network and work. And that might not be every day, but it's from time to time that will happen. So you have to accommodate for that, that problem, if you like. The benefits of Zero Trust Network Access differs depending on the team inside the network, inside your environment that you talk to. From a security perspective, it's obviously security posture, moving towards a Zero Trust Network Act or Zero Trust principle. We reduce the attack surface. So one big difference with the Zero Trust Network Access implementation is there is no VPN concentrator with a public IP address. So you can physically not attack that infrastructure. It's not exposed to the public internet. So you reduce the attack surface. You also get real-time visibility into the user and application activity because it's logged in real time. You know exactly what's being granted access to. So from a security perspective, those are really our benefits. From an infrastructure perspective, and as we saw on the Gartner poll earlier on, user experience is really important. You have improved user experience because you are sending less traffic to be backhauled. That traffic, when we access private applications, is sent more directly to the application, right? So if it's doesn't matter where that application resides, in the public cloud or private cloud, it's always going to be directly through the broker. And you could potentially be saving on your capital expenditure by reducing on-premises hardware hosting facilities, and really trying to ensure that your operational expenditure doesn't increase either. Right, so there's a lot of benefits there, and we'll talk through some of the use cases and how we use the technology. Now, there's a technical picture on the right-hand side of this, but it essentially just depicts the users at the bottom connecting through the Netskope cloud with the different capabilities that's delivered to those users and from all the different locations. And then accessing applications, and these are private applications, either in public clouds or on-premises data center. The one thing we haven't spoken about extensively is New Edge. I'm sure that you probably have heard of New Edge before, but that's really our global private cloud network with more than 70 points of presence globally today. And it is how we are able to deliver performance and quality of experience from a connectivity perspective to our customers. So the first use case is really that Zero Trust Network Access use case for users accessing private applications seamlessly, always on, regardless of where that user is. A second use case, which is quite applicable, is to enable DevOps. You have policy-based access to infrastructure as a service and dynamic workload. So being specific, allow that developer access to that infrastructure on an infrastructure as a service platform quite seamlessly and easily, while having it secured, obviously. Mergers and acquisition is another big use case. Mergers and acquisitions always require us to, or traditionally would require us to merge networks, and then sometimes you have IP address overlaps, which makes it impossible to route traffic between two networks, makes it really difficult to get two networks to talk to each other. With a Zero Trust Network Access approach, that doesn't matter. We can onboard those networks very, very quickly with users directly to applications. And then we can also onboard third parties using agentless browser-based access so that they don't need to install any software in order to gain access to applications that they need access for. So I'm going to switch and do a quick demo of how this Zero Trust Network Access, this is a pre-recorded demo, but it will give you an idea of how the Zero Trust Network Access solution from Netskope works. Now, first of all, Netskope has the ability to discover private applications in our data centers. Those private applications can then be, created based on the actual ports that's in use, and as we like to say, published through the Netskope cloud platform as a construct of one to be used inside the policy. Now, this is an example of a Zero Trust network access policy, where we're looking at specific. This is a browser-based application, so it's using a web browser, not the Netskope client. We can add other criteria like source IP, user confidence, and so on. Obviously, the source of the user or the source group of the user, and then we can also apply things like data loss prevention policies to say, in this case, we will block if there's any sensitive data downloaded from that application, that private application. So what we're going to do now is we're going to connect to that LMS. We're going to authenticate the user, giving us that identity that we need as an input to our zero trust access policy. And now the user's got access, right? They can view, they can potentially do what they need on this learning management system, which is private. But if they try and download, a lot of sensitive data, that data is being blocked from being downloaded, ensuring that we don't expose that data to a third-party sensitive. Now, let's say this user connects to the same application on SSH. We have a separate policy in place that blocks that user from accessing that application over SSH because they don't have that permission to access that application. Right. I just want to see if there's any questions, Daniel. I guess.
Yeah, there is actually questions. So one is, my customer has mentioned that they have a call center with soft phones on laptops, and they would like those agents to work from home. And if Netskope can, Netskope Private Access can meet that use case.
That's actually a brilliant segue. So the traditional issue with zero trust network access approach to security, or VPN, remote access VPN, is that server-side initiated connections is not possible. And it's a brilliant segue. So let me show you this next slide in what the advantages and potentially the limitations of zero trust network access is. We've spoken to some of the advantages before, and I'm not going to go into that in a lot more detail. But really, as a highlight, some of the challenges with deploying zero trust network access as our primary remote access VPN solution is the fact that not all applications are zero trust network access compatible. And to be a little bit more technically specific, those applications are specifically applications that have server-side initiated connections. Now, in the ZTNA architecture, we don't allow server-side initiated connections by design. Simply, we don't want to have any way that something that potentially affected a server in the data center to be able to reach back to users. But it doesn't always allow us to be flexible enough to deliver those use cases like voice over IP, where SIP protocol has a server-side initiated connection. And there are some other legacy applications that also has this requirement, right? And what that means essentially is that some customers still need to maintain a VPN footprint, some VPN solution to accommodate possibly a subset of users like a call center in a sense. And this next portion is really going to be how Netskope is addressing that requirement, right? We call that solution that we've built ZTNA Next, and it's really pioneering the endpoint SD-WAN approach. So what is this? We understand the challenges around the legacy technology, high cost operational nightmare. We've spoken about that a lot, and we've also spoken about that a lot of this is not integrated, like it's separate components. We have a VPN, we potentially have an SD-WAN appliance that we need to deploy at home or on the branch, and then we also have security services edge, and this is if we have a modern environment. Even an older environment, we might have a security stack of appliances sitting on premises in our data center, and we are backhauling all of our traffic back, which really gives us that bad user experience. So what Netskope has done is we've delivered on the first unified SASE client. And what the SASE client allows us to do is offer customers a single unified client, which includes both the capabilities of a software-defined wide area network, as well as the security services edge. So all of the security capabilities, as well as all of the network performance optimization capabilities and intelligent steering, that you would expect, right? This is not just a VPN. It is something special, and we are immensely proud of what we've done here. It is in beta at the moment. It has been built, and it is something that we can, showcase to customers if they need to see it. So the use case for endpoint SD-WAN, or which is a component of our ZTNA Next solution, is full visibility for bidirectional traffic and voice and video optimization. So it bridges that gap that we have with zero trust network access through Netskope private access, where we cannot support server to client side connections. Here we are allowing server to client side initiated connections, as well as traffic optimization, and it gives us differentiated value to our customers. It's one policy, one client. It really gives us that ability to steer traffic intelligently, also still maintain direct to cloud traffic from a user regardless of where they are in a secure manner, and protecting that channel so that we don't have any, the user has the same controls on and off the network, so we don't have any user that gets exploited remotely and now has access to corporate resources while working remotely. Right, so what does the solution allow us to do? What are the different components? Well, first of all, there's really an AI-driven operational center dashboard, if you like, which gives us insight into some key performance metrics. And it's just one of the first things that SD-WAN is always about is the network, right? Is my user's experience accessing applications of high quality? And we have this component called Apex Map, which is really like a flight tracker, monitoring every user every minute, giving us the ability to monitor and display, SLA violations. Maybe there's a poor reception on the LTE link, but this gives us the ability to identify that there's a challenge and then alert on that challenge so that we can take the necessary steps. Previously, we've been really blind. If a person's working from home, it's their internet connection, it's their Wi-Fi. It's very difficult for us to identify where that problem is. And exactly, that's another thing that we track, right? So we track things like the actual device's CPU usage, memory usage, Wi-Fi signal strength, which gives us then the ability to say quite quickly, for that device that's working from home, the user's just sitting too far away from his Wi-Fi router, and because of that distance, we know that the quality of that connection is not great. But it's not the internet, it's simply just locally on the actual LAN or potentially on the user's device. Down to really application transactions, right? So which users are accessing which applications? Maybe the user is unable to access an application. Well, that could potentially be because there is no policy allowing that user access to that application, or the policy that's applied is not prioritizing the right traffic. It might not be optimizing the voice and the video over this link, and therefore the user's quality of experience suffers, right? Which really leads me to that next point, quality of experience, right? The Netskope SASE client is not just a remote access VPN. It really is the same technology that we have inside our SD-WAN appliances for optimizing video and voice and connectivity. We have that same technology built into that client, which allows us to perform things like monitoring the link for packet loss, jitter, and latency. We understand the actual applications that users are accessing, and through deep packet inspection, and that contextual awareness allows us then to perform, understand how we should route the traffic in a policy defined way. But we are also able to mitigate poor performance by doing things like forward error correction to our users, our devices on the other side of a link that is potentially latent or has quite a bit of jitter and packet loss. And when we've ran these tests, we can see that there's an improvement. I'll show a demo in a short while around Ring Central and the quality of service report compared to MOS scores, with the agent enabled versus without the agent enabled. And also running Zoom when we introduce packet loss and what the performance difference would be for those applications. Another important aspect to consider is that the client to workload from your user, regardless of where they are, it's not dependent on a single concentrator somewhere with routing and interconnections between all of these different data centers. It is really a one-to-many type of architecture where the client will connect to any of the required headends, SASE gateways as we call them, directly. And this approach allows us to ensure that we always, again, we don't have a bottleneck of connectivity and we don't have complexity of routing on the inside of the network. Really optimized path, ensuring that our connectivity is directly to the application to reduce our latency, and then have an intelligent routing decision take place on that endpoint client in order for us to ensure that the right traffic goes to the right location in the shortest possible path. Now, this is the biggest limitation, as I mentioned earlier on, is that limitation of server-initiated traffic. Voice over IP is a very good example of that, SIP protocol and call centers. But another example of that could be a remote support engineer sitting at the office at corporate headquarters, needing to access a remote desktop session to an endpoint, working from an airport somewhere. And the server-initiated traffic is supported with this deployment where it really does enable that user to access, or that support engineer to access or initiate a connection from the other side, the SD-WAN hub side of the network, back down to where that endpoint sits. So I want to just pause here for a moment, and just give an opportunity for any additional questions that might have been asked, or if there is any questions, please ask them.
Yeah, I think you kind of hit the nail there, because there were questions around the if the performance will be degraded if this Netskope client has all these capabilities with SD-WAN and so forth that you mentioned. But I think you kind of covered it, right? That it is a low footprint client.
Yeah, I'm so yes, it is. So there's some additional capabilities that's added to the endpoint software. I have a fairly technical slide, the next slide. I want to explain how, maybe a little bit to the technical people in the audience, how we are actually doing this with the full stack. It is a single agent. It is a light footprint client, and it's obviously something that we are monitoring closely, right? So really important for us to be light. And one of the biggest ways that we are achieving that lightness is the fact that the client is really just a steering client, right? All of the heavy lifting of the security, the inspection, all of those aspects are dealt with in the Netskope cloud. The software itself is really just responsible for building overlay tunnels and then connecting users back. Yes, there's some optimization that'll introduce a little bit of CPU usage, but the goal there is to improve quality of experience, not have a negative impact on it. So just to explain what I was saying around, this is the technical slide, how we are dealing with the different components of Netskope together. Obviously, we have the secure web gateway, as well as the zero trust network access, as well as SD-WAN from Netskope. These different components, when we see a packet on the actual client software, we can deal with it differently, right? So, and the flow will really be in the order of Netskope private access. Is it steered by our zero trust network access solution? If yes, we will forward that traffic to our MPA gateway. If no, we will evaluate, is this something that should be going to the security services edge? Should it be decrypted, inspected, and is it cloud bound? Is it internet it's supposed to go back to the internet. In that scenario, we will then steer to the Netskope gateway for inspection and policy enforcement. And then if it's not, it's then going to be inspected by, or there will be a conditional check. Is it something that should be handled by the borderless SD-WAN solution, by the SASE client? And if it should, we will forward that to the SASE hub where it needs to be sent to, where we'll process that traffic, right? So that's essentially how we are doing it behind the scenes on this client. But again, one single client, one piece of software, one administrative interface. So let me go into a demo on this. Right, so networks sometimes are jittery, they have packet loss and they have latency. And in this demo, what we've done is we've introduced artificial latency and packet loss, 50% latency, millisecond latency, and 10% packet loss. And you can see here with the packet loss, when we do a ring central test, we could see a really poor MOS score of 1, which has resulted in, because of that approach. Now, a MOS score gives us an indication of the quality of the line. What we can do with Netskope is we can improve that line quality. Sorry, let me just go back to the right location. What we can do with line quality is we can improve that experience through a policy, right? Because this is an SD-WAN solution, what we want to try and do is we want to improve the MOS quality, because with a bad MOS quality, your voice and video would be choppy, it would be latent and lost. And inside the borderless SD-WAN component, we have a policy where we identify voice traffic, and then we can guarantee the quality of that voice by using that agent software in order to prioritize it and also do things like forward error correction. Now, if we run the same test with the Netskope client on, with the same amount of packet loss and latency, what we have and what we see here is we see a MOS score of 4.2, which is actually a really good MOS score, and it's something that allows us then to achieve the performance and the quality of experience that a user would expect from voice and video. Now, if we use the same technology on something like Zoom, we can see that on a video perspective, you see the left-hand side is without Netskope enabled, and on the right-hand side is with Netskope enabled. You can clearly see that there's some of the packets that's being lost in transit, and you can see that it's choppy, the video, while with the Netskope agent, because we're performing that forward error correction and the quality of the quality of service, performance routing of the video packets, we can see that connection with the client is being optimized, and the video experience to that user is obviously much better. So this is leading me into just closing out the presentation. The benefits of Zero Trust Network Access Next, ZTNA Next, is really around agility, improving that user experience for that hybrid workforce, users on-prem and off-prem, reducing the cost and complexity with a complete unified solution. So the idea is it's one solution, one agent, one management console, which means that we reduce a lot of the complexity and therefore the human effort and the cost involved with maintaining, delivering, and looking after such an environment. And then obviously, we're always trying to reduce the risk to ensure that we have an always-on security aspect. We reduce our attack surface, and we implement the Zero Trust principles so we don't grant excessive trust into any single application, really giving us that triad of agility, cost, and risk reduction to deliver on business value. So I see we have 10 minutes or so left. This is going to leave us to the next steps. Daniel, I know we're a little bit early, but it does allow us to answer some additional questions or discussion if there are anyone that has any additional questions. Daniel, are you there?
I am there. Sorry, I was unmuted. Let's give the attendees a minute or two to ask questions in the chat. There's no further questions at this stage. So let's just see if there's anything popping in. No, it doesn't seem to be coming any questions in. So with that, I think we should round it off, Paul.
Yeah, that makes sense.
Yeah. Let me see. No, there's no questions. Is there one there? Yeah, there's one. Does this mean I can retire my full pulse secure infrastructure? Is a question.
Yeah, so I guess the answer to that is yes. So the idea with this would be, and remember with Netskope, what we're trying to do is we're always trying to give customers an option, right? So the idea is that you can retire your legacy VPN solution, the hardware that you have on premises, the virtualized hardware, and you can leverage the Netskope SD-WAN component to deliver those applications that potentially still need server-side initiated connections. Of course, with a Zero Trust Network Access, the Netskope private access component, we can deliver a number of applications with that component already, but it doesn't have all of those advanced optimization capabilities, as well as the ability to support server-side initiated connections.
Mm-hmm. Okay, well, then I don't think there's any other questions. So we can round it off for today. I want to thank the attendees for coming to this event, and if there's any questions or whatsoever, then my email address was on the previous slide, and you could just reach out to us. Yeah. So thanks, Paul.